Welcome to the unit on circles. In this unit, we will be looking at the properties of chords and tangents. The objectives for this session are: find the equation of a tangent to a circle, find the equation of a line passing through given points on a circle, and apply properties of tangents and chords to solving mathematical problems. A tangent to a circle is a straight line that intersects the circle at any one point, as shown. At the point of intersection, a tangent to a circle is perpendicular to the radius of the circle. A chord is a line segment joining 2 points on the circumference of a circle, as shown. The perpendicular bisector of the chord goes through the centre of the circle. We will now have a look at the first example. Pause the video and have a go. Press play when you're ready to view the solution. So a circle has the equation x plus 2 all squared plus y minus 8 all squared equals 10. The line L is a tangent to the circle with gradient 3. Find two possible equations for L, giving your solutions in the form y equals mx plus c. Let's sketch the scenario first. The circle has centre minus 2, 8. The tangents with gradient 3 are as shown, with constants c and k unknown. We will add the perpendicular, as it is likely you will need this line, especially if you are dealing with circles and tangents. Let's now look at the steps we need to work through this problem. First, find the equation of the perpendicular bisector. We can do this as we have the coordinates of the circle which the line passes through. Then find the 2 points of intersection of the perpendicular bisector with the circle. And finally, use these two sets of coordinates to find the equations of the two tangents. Notice that the gradient of the tangent is 3. Therefore, the gradient of the perpendicular is minus 1 over 3, since the product of the two gradients must be minus 1. Now the centre is minus 2, 8. Therefore, y minus y1 equals m times x minus x1, which implies y minus 8 equals minus a third times x minus minus 2, as shown. And therefore, y minus 8 equals minus x over 3 minus 2/3. Rearranging gives y equals minus x over 3 plus 22 over 3. We now have the equation of the perpendicular bisector, which is y equals minus x over 3 plus 22 over 3. We substitute this in the equation of the circle x plus 2 all squared plus y minus 8 all squared equals 10. And therefore we have x plus 2 all squared plus minus x over 3 plus 22 over 3 minus 8 all squared equals 10. And tidying up gives us x squared plus 4x minus 5 equals 0. Then factorising gives x plus 5 times x minus 1 equals 0. And solving gives x equals minus 5 and x equals 1. When x equals minus 5, y equals 9. We've substituted in the formula y equals minus x over 3 plus 22 over 3. And similarly, when we have x equals 1, y equals 7. And therefore the tangents intersect the circle at -5,9 and 1,7. To find the equations of these tangents, use the formula y minus y1 equals m times x minus x1. For the point -5, 9, we have y minus 9 equals 3 times x plus 5. And therefore, y equals 3x plus 24. For 1, 7, we have y minus 7 equals 3, the gradient, times x minus 1. And therefore, tidying up gives us y equals 3x plus 4. Therefore, we have the two equations of the tangents. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So points P and Q lie in a circle with centre C as shown. P equals 3 minus 4 and Q equals 5 minus 6. M is the midpoint of the line segment PQ, and the line passes through M and C. Part A asks you to find the equation for line L. Given that the x-coordinate of C is 2, show that the y-coordinate of C is -7, this is part B, and find an equation of the circle for part C. Let's have a go at example 2A. Find the equation for the line L. Now the midpoint M is equal to x1 plus x2 all over 2, which is 3 plus 5 all over 2, and the y-coordinate y1 plus y2 all over 2, which is -4 plus -6 all over 2. Tidying up gives us that this is equal to 4, -5. And the gradient of PQ is change in y, which is -6, -4, over change in x, which is 5, -3. And tidying up gives us that this is equal to -1. The line perpendicular to PQ has gradient 1, since the gradient of PQ times the gradient of the line perpendicular to PQ is equal to -1. The equation of a line perpendicular to PQ with gradient 1 is change in y, y minus y1, which for our example is y plus 5, equals m times x minus x1, which is equal to 1 times x minus 4. As shown. And tidying up gives us y equals x minus 9. Now for example 2b. We're required to show that the y-coordinate of C is -7, given that the x-coordinate of C is 2. Now from example 2a, we have already that y equals x minus 9 for the line L. So if we substitute x equals 2 in the equation y equals x minus 9, we have y equals 2 minus 9. And therefore y is equal to -7. And now let's have a go at part C. We're required to find an equation of the circle. Now the centre of the circle is 2 minus 7 from the previous part. So to find the radius of the circle, CQ, we can input these values into the formula as shown. And then tidying up gives us that this is equal to the square root of 3 squared plus 1 squared, which is equal to the root of 10. So the circle has radius root 10. So using the equation of the circle formula, we can input these values as shown. This brings us to the end of this session. If you have understood its contents, you should be able to find the equation of a tangent to a circle, find the equation of a line passing through given points on a circle, and apply properties of tangents and chords to solving other mathematical problems. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.